Okay, here's what I had one up here. There it is. Okay, I'm going to tell you. Everyone see the two triangles in my diagram? I'm going to tell you they're similar. All right, I'm going to tell you. Don't worry. It doesn't even matter what the side lengths are. Does not matter what the side lengths are. Here's what I'm going to ask a couple of you to do right now for me. Woo. Using the segment names, so DB, AC, write me a proportion. Pick two sides that correspond, set it equal to another two sides that correspond. All right, up first. Up first, 22. You're going to be 22. We got a 22. Okay, ready to beast this here, Madeline? Okay, just two sides that correspond. Give it. There you go. DB corresponds with AB. Good. Just so I don't have to go back and forth, pick another number 1 through 30. 8. 8. Sorry, not here as usual. 6. Another pair. No. CE is not a full side. I'm glad. Hey, do not use partial sides tomorrow. I'm not yelling that I'm mad. I'm not. It's a good teaching moment here. Do not use partial sides tomorrow. Okay? Should be full sides only. Go ahead. DE and AC. Okay, DE and AC. I could have also substituted in what? Anywhere here? BE and BC. Can we set that up tomorrow? Okay. Now, if you're having trouble setting it up, there may be a statement given to you. ABC similar to triangle DEF. If that's the case, what would AC match up with? DF. What would BC match up with? Okay, use that instead. All right, because I'm going to give you either the diagram or I'm going to give you the similarity statement and ask for the proportion. We're all good there. Okay, let's do a little factoring, quadratic formula. Let's go to your packet. And let's hit up number 5 right now. Let's hit up number 5, everybody. After this, we'll go to a proof. Actually, I don't know if this is 5 or not because the two packets are... Which one is this one? 3? 3, number 3, everybody. 3. Go ahead, get it set up. Draw your diagram. I'm only going to put the 5 and the 8 on my triangle. I want to see what you put on BC and AD on yours. Okay, here we go. Need somebody here. What did you put on side BC? What did you put on side AD? Here you go, 23. Where?
On side CB. Or on side AD.
AD, and then what'd you put on BC? X plus 2. Everyone's ready to roll now. I have two similar triangles. Write a correct proportion. What number should not appear anywhere on this proportion? 5. It's not a full side. 5 should not appear anywhere on this proportion. Full sides only, please. Here we go. Match them up for me. 4, match them up for me. Yep. There's one match, and what's the other match? Okay, 8. What's another side of that triangle we know? Triangle ADE, we have side of 8. What's the other side we know? X. It matches up with what side in the big triangle? X plus 5. Everyone all good here? Solve it. Here we go. Cross multiply for me. Let's go. 29.
X plus 2 times x. 2x plus 2. X squared plus 2.
Plus.
8x plus 5.
No. Whoa, whoa, whoa.
Plus 2x.
Plus 2x, and then watch your mouth over here. 8x plus. Are you comfortable tomorrow? Hey, are you comfortable tomorrow multiplying something like this? X plus 8, x minus 4. We okay there, guys? You may have to do that tomorrow. FOIL, double distribute tomorrow. All right, you may have to do that. Okay, going back to this problem. What's the next step? Going to get everything out of you guys. No 27. Or do we have a 27? Nope. How about a 14? Next step. Please do so, Caleb. X squared. X. What's going on? There we go. X. Anything? Oh, that's because I'm on white. It would help if I'm on black. One job, buddy. One job. Of course, you're not going to see the white. Try that again. Go ahead, Caleb. X squared. Minus 6x. Yep. All right, can we have a class decision? How do you want to proceed? Factor or quadratic formula? How do we want to proceed? You tell me. Oh, boy. Can I see all the factors? Okay. Okay, how about I do it both ways? How about that? I'll satisfy both types of people here. Two numbers that do this, multiply to this, and add to this. Six. Were you a factor or a quadratic one?
Quadratic.
Okay, I'll get back to you. 24. Were you a factor or a quadratic? Okay, you're up. Two numbers that multiply to this and add to this. What are those numbers? Multiply to negative 40, but add to negative 6. Nice job. Nice job. All right, I'm going to stop there. Let me go to quadratic formula, people, now. X equals. Nika, going back to you. What's your B value?
Negative 6.
Negative 6. So when I plug it into quadratic formula tomorrow, it'll be 6 plus or minus square root. I'm going to store. Oh, boy, I have no idea. It should be a perfect square. I know that. 196? Is that what I'm getting underneath the radical? Buck 96? All over 2a, so 2 times 1. All right, where are my quadratic formula people here? Square root of 196. Plus or minus 14 over 2. We did this yesterday for 2 nights ago for homework. How do you get your two answers now? Where my two answers come from? 6 plus 14 divided by 2, and 6 minus 14 divided by 2. All right, let's go back up here. Factoring people, one answer would have been 10 and negative 4. Quadratic formula people. You good? You sure? All right, that's what I thought. Okay. Quadratic formula, people. 6 plus 14. Divide last. Oh, shocker. You get 10 and 6 minus 14. Negative 8 divided by 2. Okay, either way, you still get those two answers. What do we have to worry about tomorrow, though? Here you go, 20. Okay, not because it's negative. Why can't I use negative 4? If I plug it back in, I'm going to get a negative side length. Goodbye. Goodbye. Discipline tomorrow. What was I asking for in the problem? The length of segment AD. What did we label AD as? Okay, X. So I don't have to plug it back in. It's 10. All right, quadratic formula, people. Factoring. Either way, we're good to go. Yes.
Just real quickly, where are you getting the 196 from?
Okay. You have an A, a B, and a C value, correct?
Yes.
Okay, so I have an A value of 1, a B value of negative 6, and a C value of negative 40. We're good with those values. I go to my calculator. I take 1, store it in for A. Maybe. Store that in for A. What was my negative 6 was my B value? Negative 6. I store that in for B. Not twice. How about just once? 40, right? Negative 40. Negative 40. I store that in for C. And I ask the calculator to please give me the value of B squared minus 4AC, the part underneath the radical in the quadratic formula, and that'll give you your 196 back. Okay? We're all good there. Okay, proof time. Here we go. Little proof. We did that one already?
No, I didn't.
You did it? Okay, number 4. Fine, perfect. Number 4. All right. Everyone see the proof statement. How is this proof going to end? When I see that as my proof statement, how is this? Just keep in the back of your mind, don't write anything down. With what reason will this proof end with? Who's last up to go? Well, so pick a number, 1 through 20. Oh, 1 through 30. 17. How's this proof going to end? Good. That's how it's going to end. But I can't get there unless I know what about the triangles. If they're similar. Guys, I see 1, 2, at least 3 different triangles here. What is going to help you determine which one's the proof similar? Proof statement. Do it with me. Ready? What's the first? It was number 2. Who's 2? You're up next there, stud, when I ask the next question. You're not off the hook. Okay, everyone with me. Ready? What's the first segment? AB. Ready? I highlight AB. I think that's only a full side in one of the triangles, right? I can't find another triangle where that's a full side. So we have the first triangle. What's the next segment? DE, so I highlight DE. How many triangles does DE belong to? Just the one there, so we found it. Now, what if it belonged to 2? Keep going in the proof statement. Start highlighting more segments. You'll figure out which 2 triangles it'll need to be. All right, main method I'm going to use here to prove them similar. Angle, angle. Find me 2 angles. All right, find me 2 angles right now. 1. Got an angle there, Maddie?
Angle B equals angle D.
You got it. B and D are congruent. You're never getting away from quadrilaterals. B and D are congruent. How does Matt know that? 17, how does Matt know that? Ooh, not yet. They're not alternate interior. I'm talking B and D. There you go. Opposite angles congruent. Nice job. I don't know if anybody was listening, but she kind of held your hand for the next pair of angles, but we'll see if anybody was listening or knows. There's 1 pair. Where's the other pair come from? Name them. 10. Name the other pair of congruent angles. Oh. How about 13? Whoa, whoa, whoa. Hold on. I got to get my game together here. Okay, go ahead. B, C, E. I got it. This one with which one? C, E, D. Yep. Did anybody want angle A and angle DCE instead? You could do those. Those are alternate interior. All right, but we're going to go with this pair. That's the one Emily gave me. If we're going with these pair of alternate interior, what lines need to be parallel? This kind of drives me nuts a little bit. Can you identify the lines that need to be parallel before these alternate interior angles are congruent? What lines do I need? 12? There you go. BC parallel to FD. And how do we know they're parallel? 17, how do we know they're parallel? Yep, parallelogram implies opposite sides parallel. Then you could say those angles are congruent. Angle BCE congruent to angle CED. How about a reason? We've already kind of discussed it, but what's the reason? 7, great job. 28, great job. 10, awesome job. 12, do we have 2 pairs of angles? Now we could say, what about the triangles? They are similar. Write a nice similarity statement for me now. 11.
Triangle
CBA
CBA is similar to triangle
EDC. By?
Angle.
Okay. Now is here where I start to get worried for you tomorrow. Because you cannot go to means and extremes unless you have means and extremes. You got nothing to cross multiply right now. So don't go to the proof statement. What do I still need to build before I get to that proof statement? A proportion, so I have means and extremes to multiply. How do I build that proportion? Well, if I'm supposed to multiply AB with DE, where do they have to be in the proportion? Diagonal, so I can cross multiply with them. So AB, somewhere, place it somewhere, but diagonal to it's got to be DE if I'm going to cross multiply with it. And then the other 2 slots are for CD and BC. Not because the means and extremes are equal. Why are the ratios equal? 12. Ooh, we better get that right. That was a lot of no. C at corresponding sides in similar triangles are proportional. Then what can we do? Multiply the means and extremes. AB times DE equals BC times CD. Product of the means equals product of the extremes. Guys, please, please, please make sure we know the correct order here for tomorrow. Am I going to go all the way to means and extremes? Maybe. Am I going to go all the way to CSSDP? Maybe. All right, but just make sure you know the order it's got to go in and the statement that's got to go with it. Questions there? Going. Okay, last one I'm going to do with you is number 1. And then I'll let you go on your own, Nate and his flagpole. Okay, Nate, 5 feet tall already. I'm not creative enough to draw Nate in, all right, fully in. There's a flagpole that's 60 feet tall. And again, anytime we're standing on, anything's on the ground, standing on the ground, built into the ground, we're going to assume it's perpendicular, forms a right angle. He places a mirror on the ground 4 feet away from him. Right? Mirror, whatever, 4 feet away. I just wanted to get the setup here with you. How far is he away from the building? How far is Nate standing from the building? All right, so I need to find this entire distance right here. Well, I got the 4 feet, but I'm missing what? What's going to help me finish this one? If I knew the distance from what? Thomas? The mirror to the flagpole. If I knew the distance from the mirror to the flagpole, I'll add it with 4 and I got the total distance. Okay, can I find that distance? I know you don't see it here, but these are triangles. What's the 5 correspond with? Don't say a word. 1, what's the 5 correspond with? The 60. And in the same triangle, what's the 4 correspond with? 18? X. Okay, so I can use similar triangles here to find the flagpole to the mirror. And whenever you're ready, take your time. Whenever you're ready, 29, when you find X, 48. Is that what I want to box in and say that's my final answer? No. Nope, because I was looking for from Nate to the flagpole. You want to finish this one off and give me that one from Nate to the flagpole? Here you go, 3. 52 feet, got it. Before I let you go on your own, go ahead. Well, the X plus 4 would be this whole distance here, right? X plus 4, but the problem is that's not a side in either of the triangles. Remember, all I need is full sides in the proportion, all right? X plus 4 would be the side, this whole distance I'm looking for, but it's not a side in the triangle. Can't use it in the proportion, okay? Before I let you go on your own, you guys know you got the answers in the back. There's textbook questions to try up there. Today, I'll be here at starting at 2:40, Okay, I'll be in this room starting at 2:40 if you want to sit down and review anything with me. Anything. First grade of the third quarter. Let's get it off on the right foot. Go ahead, start either in your packet or grab a textbook. I'll walk around helping you guys out. Please don't start packing up and heading to the door.